Well, okay, let me think. So I want to give you some advice regarding your Monopoly simulation without giving you like exactly how to do it. But I'll tell you what I did, okay? So at the end of the day, so in tic-tac-toe you had to program a whole bunch of functions, okay? In the Monopoly, I don't think you're going to need to program that many functions. I only ended up having 3 functions in the global environment. I had a function for the chance deck, a function for the community chess deck, and a function for taking turn, okay? Everything else I put in as methods in the player reference class, okay? In the player reference class, I built several methods. That you're going to want to expand the number of fields in the player reference class, and you're going to want to add some methods to the player reference class. But all of those things handled, what going to jail and all of that stuff. Okay. At least for the chance and community chess decks, I would rather than I don't know, passing certain arguments, I would say the argument that you should pass to the chance function or community chess function, if you choose to implement it this way, I would say pass the actual player object, okay? So, when you simulate a game, you're going to use the reference class to create new players, right? You'll have player 1, player 2, things like that. And when you call the chance deck function, you want to use it as a function of the player, okay? And that way, if the chance deck says move the player to another space, you would pass it. Here, let me just kind of illustrate what I'm talking about here. So you would have something, right? You'd have chance. I don't know, chance function, okay? And this will be an object, okay, so it'd be a function of player, okay? And inside here, right, it's going to be like if, you're going to have like, card is going to, let's see, am I doing too much here? You're going to do sample 1 through 15, right? Okay, you're going to draw one card out of the deck of 15. I don't think I'm giving away too much here, right? And then it's going to be like if card is equal to 1, and I don't know what the first card is, but maybe it's like advance to go, right? You want to give it something like what you want to do here is, because you're giving it the player reference class, you can do player $, and you can call the method something like whatever, go to space 1 or something like that, okay? And this way, because it's a reference class object and you call the method updates the object itself, right? So make your function a function of the reference class. This is how using a reference class is going to make your life way easier, okay? Because otherwise, you're going to have to do something like, new position is going to be is 1, and then at the end of the function you say, return new position, and then at the end of the function it's going to be like if you drew the thing, you're going to have to be like player $ position is going to be what the function returns, okay? And you don't want to have to do it that way. So just call the thing and then call the method within the player object, okay? Such as go to space n. Okay? This is going to make your life better.
So you're saying generally it's just going to be easier to just implement these things as functions within the player class.
Right. So you have methods, okay? You're going to have to figure out what methods you need in your player reference class, okay? I've given you 2 big ones, like rolling moving this and going to space this, right? And pretty much the chance deck is pretty much just going to be using these methods. So you pass it the player reference class object, and then you you call the method on that thing. And this way you don't have to worry about what the function returns and then capturing that return to output and then updating your player objects this way. So I think if you do it this way, it'll make your life easier. Yeah.
Is this what you mean by hard coding?
Yeah, so hard coding by basically we can just say the first card, at least in the chance deck, is advanced to go, or whatever it might be, okay? You don't have to... Basically, I'm saying you don't need to write a function that reads the card and then interprets what the significance of that card is, right? You can just go off of the index of the thing, right? Because in reality, what we do is we draw the thing and we read the card and then we say, oh, this is what I have to do. In this thing, it's just, the cards might as well be blank and they just have a number on it and you're just going to draw. Card 5 says do this and you do that, right? And then... and something like that, right? Some of the things will depend on where the player is located when you draw the chance card, okay? And because you're passing it the player object, you can reference those things, right? You can say if player $position is equal to this, then I know this is where I'm going to be going, type of thing, okay? So you can... so you know when you're creating your chance functions, something like that. I don't know. Okay. And then you could even. Am I saying too much here? If you want to update where you're tracking, if you're updating your tracking space, you'll probably want to pass that as an argument as well, right? So almost all of these functions will probably be take two things, which will be the player object and the tracking object type of thing, okay? Because a lot of these things you're going to be updating your tallies, right? So, okay. And if you have questions about what happens when you roll this or when you move like this, I think a lot of those questions are answered in my 20 fixed turns type of thing. I know the 20 fixed turns doesn't call the chance deck very often, and that's because I wanted to try to avoid a whole bunch of random number generation stuff. So, but using the fixed dice, it'll show you like when you're in jail, when do you put a tally in jail, and basically every time you stay in jail, you're gonna put a tally in there. Okay, and I think if you write your code this way, the games will run quickly. Okay, rather than. So you can run through 1,000 games in maybe 3 minutes or so. I was timing it earlier and it wasn't so bad. It was like maybe 5 minutes of runtime, and not 800 lines of code where it's taking an hour to run 1,000 simulations. Okay, because the purpose of these large scale computational simulations, it's supposed to save us work from doing math. So. Okay. Yes.
I'm a little unclear on the two chance or community decks.
Uh-huh.
There's a bunch of cards that don't really have any movement involved. Do you want us to still cycle through those?
Yeah, you don't have to do anything with those, really. I mean, the cards that don't update your movement, you don't really have to worry about them doing anything. Okay? It's just going to be draw a card. Okay, I do nothing as far as movement goes. Okay. You're going to find jail is the most frequently landed spot, okay? And then the other ones that will be frequent will be Illinois, Illinois Avenue, I don't know, Go, stuff like that, yeah.
Are visiting jail and jail itself two different spaces?
It's the same space, so they will both count as having landed on jail, but when you're visiting jail, you are not constrained to roll doubles on the next turn or something like that. You don't have any of those things locking you in place. It's, like riding a bicycle or driving a car. The first time you do something, it's awkward and clumsy. You'll get better at things, right, with practice, just like everything in life. So, so that's that. I today I wanted to take time and look at an even more complicated simulation and just show how an even more complicated thing is broken down into, you know, easier pieces, smaller pieces, piece by piece. This is not meant to be model your Monopoly code based off of this thing, because Blackjack, so we're going to take a look at Blackjack. It's a card game that you play at the casino, and I'll explain as we go along. It's very different from the Monopoly thing, but I think these are both good examples. So the Monopoly one is your task. The Blackjack things that, you know, what we'll look at today, and they're both good examples of using the computer to answer a lot of these complicated questions that are probabilistic or statistical in nature, yet trying to do all of the math behind it can get out of hand. And so running simulations and things like this can help us get at these questions. And I think this is a large part of computational statistics, where we're designing simulations. And this is an example where the game of Blackjack, if you've played it, the basics are simple, but then there's all of these other things that can make the game much more complicated. And here we're going to break it down into manageable chunks. This is just one chapter coming out of this excellent textbook or something called Data Science in R, a case studies approach to computational reasoning and problem solving. It's available for free for students via CRC base. You can look it up there. This chapter was written by Hadley Wickham, so his code is very good, and he doesn't waste a bunch of lines doing meaningless things. Okay, so I think we can learn a lot from looking at people who write very good code, and try to take tips from that. Okay. And you know, if you have time to look at some of the other chapters, there's some really neat projects that they've done in this textbook. So I recommend taking a look. Okay. So anyway, so Blackjack. Have you guys gone to Vegas and played Blackjack? I don't even know how old you guys are, but so anybody? Okay, a few of us, right? Okay, so most of you have not. Okay, so the older ones of us have. All right. Okay, long story short, don't go to Vegas hoping you're going to win money, all right? It's not designed that way. However, you know, if you know full well that what you're doing is you're paying for entertainment, then it's fine, right? It's not much different than what spending on a movie ticket, but maybe it's a little bit higher, more expensive it can be, right? Or a show that leaves you sad at the end because you lost your money. So anyway, okay. So the idea in Blackjack is you get dealt 2 cards. The dealer gets dealt 2 cards. Okay, and each card has a value, and you add these values up, and it's whoever can get closest to 21 without going over 21. Okay. So the best case scenario is you get 21, and the dealer gets a number less than 21 or goes over 21, and in that case, you win. However, there is so you deal yourself these cards. All the cards are, you know, ace through 10 is just worth whatever it is. Ace is worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The jack, queen, and king are all worth 10. So there's 4 cards in the deck, or in each suit, that are worth 10. And then the ace is worth 1 or 11, okay? And so the best hand that you can be dealt would be 1 10 and 1 ace, and that's known as Blackjack, okay? And it's whether it's a 10, a jack, a queen, or a king, it doesn't matter. A face card or a 10 with an ace, that's Blackjack, and that's an automatic win, okay? If you get dealt that. Unless the dealer also gets dealt that, then it's a push. But if you go as you're playing, the way the house maintains its edge is that you have to make the choice of whether to draw another card or not without seeing what the dealer has. Okay, so you have to make all of your decisions first, and this is what puts you at the disadvantage. Okay, and so you know, maybe you're at 16 points. Okay, so you have a, let's say you have a 6 and you have a 10. You have 16 points. You draw another card. Okay, because you want to get close to 21. If you, the best case scenario is you draw 5 or something less, right? And then you get closer. Okay, if you draw a 6, your thing is now has 22 points, and that means you've lost. Okay, once you go over 21, you lose. Game over. It doesn't matter what the dealer has. Whatever the dealer has won. You've lost your money. Okay, and there's all these other things, like if you get dealt 2 8s, or you get dealt 2 of the same number, you can do something called a split. Okay, so normally 16 is like considered the worst hand you can be dealt, because it's a tough choice, right? Because the way the dealer plays is that the dealer keeps drawing cards until they are at 17 or higher, and the dealer has to stop at 17. So if the dealer has 16, the dealer has to draw a card, and that might force the dealer to bust and you win, but the dealer has to stop at 17 or higher. And so 16 is kind of at this point where you might lose to the dealer, you might not, and so it's a tough thing. And if you get dealt 2 8s, you're given the option to split, and that basically allows you to take your 8 and your 8, and you pay more money, and now you have 2 hands, and you're playing 2 simultaneous hands, and they deal you a card, 1 more card for each thing, and so you might get an 8-10 on this one, and then 8-3 on the other. This one is 18, and you choose to play accordingly. Over here, it's 8-3, and you choose to play accordingly. It's 11. You're probably gonna double down. Okay.
Do you have to choose which deck you want to play with, or you play with them?
You're playing both of them simultaneously. If one busts, you've lost the money on that one. So to play simultaneously, you have to put down another full bet, right? So like if your original hand, you bet $10 to play this one hand, and you want to split it, you have to put $10 again. And so now you have 2 hands that are both playing $10. Okay, and then they're played separately. Okay, whether they split, you know, push or bust or whatever. Okay, so just some terminology to throw out there. Bust means you went over 21, you've lost. Okay, push means your hand and the dealer's hand are tied, and nobody wins, nobody loses money. Okay, and then a win is a win. You get if you put $10 down, you get $10 from the dealer or from the house. And then a blackjack, most casinos will play this way, and you should only play, if you're gonna play blackjack at a casino, make sure they pay 1.5 for blackjack, otherwise they're cheating you out of your winnings. A blackjack, if you get dealt an ace and a jack right off the bat, you get 1.5 times your winning. So that's, if you have 10, you'd get 15. Okay, and they always round down. So if you play 5, they're only going to give you 7. So always put an even number there. Okay, and I'm trying to think what else is there. Oh, there's something called double down, which is you agree to take 1 more card, but only 1 more card, and you're betting more money. So let's say you get dealt, I don't know, an 8-3 on your first 2 cards. You have 11. And because the most common card in the deck is a 10, you're like banking on the fact that a 10 comes around. So you might say double down, so you put down another $10, so now you've played $20 on this hand, and then they do your thing, and you're hoping you win. It's possible they deal you a 2 and you lose, okay, and you lose double your money. But in that case, you know, you can come out ahead as well. So that's that. There's hit means I'm going to draw another card, okay, and stand means I'm done drawing cards. This is the hand that I'm going to put into play against the dealer's hand. All right. So anyway, all of this stuff is sounds like a lot. again, just like all of these other games, you can watch videos of people talking about how to play this. So if any of this doesn't make sense as we work through the code here today, you can take a look at the code. You can read the text, which I think is very good, and you can also watch videos on how Blackjack is being played. Okay. All right. So first, we're gonna begin with a shuffle with replacement deck. Okay. Or again. So generally, in Blackjack, you can do something called card counting, which is discouraged but not illegal, and you can count the cards, and actually, if you do it successfully, you can actually eliminate the house edge and actually come out a tiny bit ahead in your earnings, right? So most of the time, you're gonna lose these casino games in the long run. But if you're counting cards successfully, you can come out ahead, all right? And there's all sorts of strategies and as far as card counting goes. Most of them are, you try to keep it simple. You either go up or down in a count. There was a movie that came out maybe 10 years ago now called 21, and it was about this, it was loosely based on the MIT Blackjack team. and there's this whole discussion about anyway, but and so anyway, they came up with a system, and basically they won all of this money, and then maybe they got roughed up by the casinos. but anyway, so card counting has been around, and the casinos might tell you you're not welcome to play here anymore, but they can't send you to jail for card counting. Okay. All right. So anyway, we're gonna just start off with a simple deck, and the deck here is just ace through 10, and we're gonna repeat that 4 times. So we have a deck of 52 cards, and then we're gonna build a simple function, which is just shuffle the deck. Okay. So we take the deck, and we're gonna shuffle them. Here we're gonna repeat this entire deck n times, because most of the times you don't play with a single deck of cards, but you play with maybe a stack of 8 decks or a stack of 6 decks or something like that. Okay, and then they just draw it from this tray called a shoe. And okay, and then we implement this function called hand value. All right, and maybe let me scroll up over here. Okay, so here we're gonna create our deck. We shuffle our decks. That's a function. Okay, so I can just do shuffle underscore decks, and we'll shuffle just one deck, and that's a deck of 52 shuffled around. And here's 2 decks, and they're arranged, and we can see their values here. Okay, this is a function that's going to calculate the value of our cards. Okay, and so normally you would just take the sum of your cards, just take the cards and you just sum them up, okay? And that's generally your hand value. But because there is the ace, which can take on 1 or 11, whichever one is more advantageous for you, we want to take that into account, okay? And so our value is gonna be, just add up the cards. This is the base part here. But then if any of our cards is equal to a 1, and the total current value is 11 or less, we're going to add 10 to this, okay? And this way we will not bust, right? So if we have, 10, 10, 5, and an ace, I'm sorry, not 10, 10, 5, 10, 5, and an ace, at that point, we would add them up and we would be worth that 16. 10, 5, and ace would be 16 points. We don't want to add 10 because that's going to cause us to bust. Okay. However, if we have a 5 and an ace, that would be 5 plus 1 is 6. In this case, we want the ace to be worth 11, and so the 5 and the 1 would give us 16. Okay. So we would do value is over 10. We'd do value plus 10. That's going to give us our thing. And then we're also going to just check And here's how we're going to keep track of whether we've busted or not. If our value goes over 21, our hand value is going to be worth 0, okay? And we're going to just say this is a losing hand. Otherwise, we're going to give ourselves the value of 21.5 to just say, because the way we're going to just compare whether we've won or not is we're going to just look at hand values, and whichever hand value is worth more is going to be declared winner. So if we say we're going to turn busts into 0, then that hand will be a losing hand. And if we have a blackjack versus a 21, we want to give the blackjack a slight edge, and we're going to give it that 21.5. Okay, so this is how we'll keep track of hand values. Yes?
So do you need to keep track of if you bust and you have a 1 in your hand?
I'm sorry, a bust and a 1 in your hand?
So like you had an ace and then you reconsider the ace's value?
Oh, no, yeah. That's taken into account here. So we start off with the value of our cards just by adding up our cards. So this starts off with the ace being worth 1. And in this case, we only increase if the current sum of our cards is 11 or less. Okay? So when you play blackjack, oftentimes you're saying, oh, this is 16, I got dealt a card, oh, now I'm going to bring my ace back down to 1. In this case, we're actually calling the hand value function on the cards every single time, and so every time we call the hand value function, it's going to start off saying the value is just adding up the cards, so we don't have to worry about changing the ace from an 11 back to a 1. It's just going to say, every time it looks at it, it just sees the ace as a 1, and it says, should I add 10 to this, yes or no? That's what it's doing, okay? Yeah.
So for the shuffle deck, you shuffled one deck, right? And
Yes.
that's the output. How do you get that many 10s? Oh, and one on top. Yeah,
Oh, yeah, because the jack, queen, and king are all worth 10, okay? And in blackjack, the suits don't matter. It's just the face, or the value of the card, okay? Okay, so we do this. This is our hand value function. Okay, and here, this is how we decide whether we have won or not, okay? So this is a function of the dealer and the player's hand values, okay? So what we do is, you shuffle the deck, you draw cards, and we're gonna say like, the player gets a certain cards, and here we're just gonna say, how much is the dealer's hand worth? Is the dealer hand worth, 12? Is the player's hand worth 15 or something like that? This is what we have, okay? And so basically, we're gonna say if the dealer's hand is over 21, okay, that's the only time you can go over 21, because in our hand value function, if you've busted, your hand value is now worth 0, right? So you can be over 21, and in this case, because of the way we're calculating hand values, going over 21 is a good thing. So if the dealer has over 21 and the player is anything less than a blackjack, then the player has lost to the dealer. Okay, so if the dealer gets a blackjack and you have not a blackjack, you lose. Okay, so but if you get blackjack and the dealer has anything other than blackjack, then you win. Okay, so we're gonna say, we're gonna look at the dealer, we're gonna do 1 minus, okay, and this is illogical. This is gonna get coerced to a 0 or a 1, right? So if player is less than or equal to 21, this is gonna be a 1, so our winnings will be negative, okay? We've lost, okay? Otherwise, if the dealer has busted, we're gonna say dealer busts 0, okay? If the player has blackjack, we get 1.5 times our winnings. If the player is anything other than bust or blackjack, we get 1 times our winnings will be 1. And then if the player has also bust, then we are at -1. Okay? So if you bust and the dealer bust, you still lose. Okay? If you bust, you lose no matter what. That's how the house maintains their edge, is that your decisions go into play first. And then down here we have, if the dealer's anything less than 21 or below, okay, we're gonna see if we win with blackjack, we would get 1.5 times our winning, or 1.5 times this logical statement, okay? Over here, it's we win if player is greater than the dealer, okay? So this becomes a logical, and we will win there. And if the player is less than the dealer, we will lose, okay? So this will be a logical true or false, and this is what we have. So the winnings will return either +1, -1, or 1.5, depending on how we compare to the dealer. So I can just do winnings. So if the dealer has 21 and we have 20, the winnings will return -1. If the dealer has 20 and we have 20, it's going to return 0, okay, because that's a push. If we get 21 and the dealer has 20, we have that, all right? So this is what we have. And if we get blackjack, then we get 1.5. All right, so this is, we're giving it our values, okay? This is an even more concise way of determining winnings. This will also work. These are just taking advantage of R's logical coercions to 1s and 0s, right? So, you know, this is how what happens, okay? So we can do this. And much like everything else, we can, it is a good idea to test our functions to make sure they are behaving the way we want them to behave, okay? So as you guys are working through your Monopoly thing, I strongly encourage you, the reason why I gave you that manual dice thing is so you can test out if your functions are actually doing the things they're supposed to be doing, okay? So in this case, we're gonna ask our hand value function to see if it truly adds up the way we're supposed to, and so we can give it a list of test cards, and we can do an sapply. We're gonna take our test cards list, and we're gonna apply hand value, the hand value function to them, okay? And we can see, does this return what we're expecting? 21.5 for the blackjack, 21 for all of these other things, and we can check, okay? We can do this using the identical command, which will check to see if these two vectors are identical. And so we can create the vector of what we're expecting to get, and we can compare it to the output of sapply, okay? So we're taking our values, 21.5 and all of this, is that identical to the values that we got here? I think the sapply is good enough, but here, this is all of the different hands that we want to test out here. Okay, and then lastly, we're going to see if our if the winnings function returns exactly what we're expecting to do. Okay, so we're going to create a matrix here. Okay, so this is what test winnings looks like. Okay, and this is what we're expecting. Oops, let me give that. So this is what we expect to happen, okay, when if the player has 0, 16, 19, 20, 21, 21.5 versus the dealer having any of these things. This is what we expect. This is something we manually programmed ourselves, or not programmed, but manually wrote up ourselves in this matrix right here. And here we're going to just do a quick check running through our winnings function to see if this is behaving the way it's supposed to, okay? And so I'm creating an empty matrix called check. All right, I'm taking my empty matrix check, which is just full of NAs now, okay? And we're going to just go through each thing, and what we're doing is we're just going to run the winnings function on each coordinate and just see if the winnings function fills out our check the way we're expected to. So we're just going for each row and for each column, and when we do that, we see that the check gets filled out like this, and we compare the check versus our manual table of what we expected, and we see that indeed they are identical. Okay, so this is all just checking to make sure our hand value function and our winnings function are working properly. Okay. All right. So here we're going to create a function on drawing drawing cards from the shoe. Okay. And so all the shoe is doing is it's going to take a deck, and then it's going to draw from the deck. Okay. So shoe, it just takes we're just going to draw M cards from the shoe, and all we're doing is we're just drawing from the deck with replacement. So we do this, and so our shoe is just a function. And so if I say draw 3 cards or draw 5 cards, this is what it looks like. And a new hand is a function where we're going to it's a function of the shoe. Okay, so inside the function for creating a new hand, we are passing an actual function here itself. Okay, so we are passing the function shoe into here, and we're going to create a list of, or a vector of cards where we're calling the shoe function, and we're going to just keep track of what our bet is. Okay, and so this is going to return. Whoops. So if I just say new hand and call the function, oops, argument shoe is missing. So new hand is a function. I have to pass it the shoe. Everything else has default values, so we're going to pass it the function shoe, and it will within the new hand object, it has the function for drawing from the shoe. Okay, so this is one of the nice things about R, is you can pass functions in as arguments for other things. Okay, we had a question. Yes.
Can you explain one more time what a shoe is?
So the shoe is our function for drawing cards. Okay, so right now we're just drawing from a deck with replacement. Okay, and later on we want to be able to have a deck that is, we're going to create a reference class so that we can actually keep track of all the cards that exist in our deck, all the cards that have been played. But as far as we've gone so far, this is just the shoe function is a way to draw cards from the deck. Okay, all it really is just sample cards from the deck. Okay, but later on we're going to want to change the function for the shoe to something else, and so we keep track of this as far as getting a new hand goes. Okay, and here we might want to just say use a reference, not a reference, use S3 object, and we're going to just give it class hand. Okay, so same as before. If I say give me a new hand, now it has everything else, and now it has the class as hand. Okay, and this just allows me to modify the way a hand gets printed out by creating a method called print.hand, right? So print.hand, it's just going to print it a little bit differently, so that rather than getting it this way, when I call new hand on the shoe and set the bet equal to 7, the way it's going to print out now is it's going to print out this way. It's going to say Blackjack hand, these are your 2 cards, 2, 9, it's worth 11, and your current bet is 7. Okay, so it's just a way to capture the way the hand information is stored. Okay, maybe I can do just as.list my cards. Okay, it's still. Let me just change the class. Class on my cards. We'll just set to null here. Okay, so this is the information stored in my cards, but because we're calling it, we're giving it the class hand here, the print method for hand shows up. Okay, so it's just the same information to say that the card's 2, 9 and your bet is 7, and it's just going to show up this way. And what it does is it calculates the hand value and it throws that in there, which is useful to us. Okay. And so this is where we're going to start programming kind of the functions that take into account these objects here. Okay, so here we're going to hit our hand. Okay, and what we do is it's a function of the hand, and what the hand cards are going to do is it's going to notice I'm passing the entire hand object, and what we're doing is we're updating the cards in the hand to be the current hand cards, and then we reference the shoe function within hand. Okay, and we're going to say just draw one card from the shoe, because the shoe is a function to draw cards, and we update our cards there, and we're going to return the hand. So this is a slightly different from a reference class, but the idea is still the same. We're passing it the entire object rather than just one value from the object, because the object contains several values, right? It's like a list, or it has fields. We're going to pass it the entire thing, and we're going to take advantage that we can look at all of these things in there. Okay, but because it's not a reference class thing, we our functions will have inputs and outputs, and we're going to update them that way. So we do we're going to function create run that. So when we hit our list of my cards, which is has a 2-9 right now, it's going to return back an entire hand rather than just do that. So I hit my hand, I drew a 7, now it's worth 18. Okay, and I can hit again, and oh, I'm sorry. So if I do hit my cards, it's just drawing one card, and so this is because I haven't updated my hand yet, right? So each of these times I'm passing it my cards. What are my cards? My cards is just has the 2-9, right? So if I wanted to actually update my cards, I would have to do my cards hit my cards, right? So this is how we would have to actually do it. And then I would look at my cards, and we'd see this, and we're at 21. And if I were to hit it again, we would see we have busted here, okay? And then so I probably want to do my cards is new hand, and we have to give it the shoe, and I don't know, what did I say, bet is 7 or something like that, right? Okay, so so this returns it, but we have to capture that output. We can't, something just happened. What did I do? We have to capture that output if we want to keep track of it in this case, okay? Because these are not reference class objects. These are just regular old functions with inputs and outputs, okay? We can create other functions. In here, the stand is going to be just return the hand. So we do no action, we just return the hand. Okay, and it seems kind of, you guys all right? It seems kind of silly that we're doing this, but we're just returning the hand when we stand, okay? Double down means we're going to modify our bet by doubling our bet. We're going to hit our hand, and then we're going to stand, okay? So here we're going to update our hand by hitting it, okay? So this is where we can see we hit the hand and we actually update the hand, okay? And so again, we are modifying, we're passing it the entire object which has all of these other things. And this way we can, you know, when we call hit, hit is a function of the hand, and it references the shoe in there, okay? So we're doing all of these things. But I think, you know, doing it this way, in this object-oriented style, makes our life easier. We don't have to worry about all of these little nitpicky things. We just have these kind of the functions associated with the object itself, or the methods associated with the object itself, and we can just do these things. And this makes our reading of the code a lot easier than the thousands of lines of code that might be used otherwise, okay? And so we can just kind of see, all right, let's take a look at my cards. Right now we have a 4 and a 1, 4 and an ace, which is currently worth 15. If I double down, I got dealt an ace, okay? And so now it's going to be worth 16 points, okay? And that's like your, well, you don't want to double down on a 15. That's ill-advised anyway, okay? And here's a function for splitting a pair, right? So we didn't, right now there's no, we're not checking to make sure you're even allowed to split pairs. This is going to just split a pair whether you give it, whatever you give it, okay? But notice what it's doing here. It's going to return back a list of 2 hands, okay? It's going to return back a list of 2 new hands. And what is the new hand? The new hand is going to take the current shoe that exists for this hand, and then it's going to update our cards by taking the first card and drawing 1 card from the shoe. And it takes our bet, okay? And then the second hand is the same thing as this one, except the first card in this thing is going to be the second card from the currently existing hand. Okay? And so let me just take a look at my cards. So my cards is a 4-1. Technically, you can't run a split on this, but we will just do it anyway. All right. So I'm gonna do split this pair here, and we can see we've taken the 4 and we've created a new hand here, and we've taken the 1 and we've created a new hand over here. Okay. And so this is the split hand. Okay. It's a list of 2 hands. All right, and so, we've run out of time before we got really to the interesting parts here. Well, if you've got time, read through the PDF that I've posted, okay, and I'll decide whether I want to continue this on Friday or not. Look at this in more detail, or maybe we'll just start something else. But we'll go there.